Okay, so let's talk about AP 8.4, 8.5, and 8.6. It sounds crazy to talk about 3 sections in one short video, but these sections are all really related to each other, and they all have to do with the area between two curves. So before we talk about the area between two curves, just want to remind you of a couple of basics of the area under a curve. So remember when we built these as first, we divided into sub-intervals because we were doing like approximations, and then we built these rectangles. I'll use a right Riemann this time. And we found the width of those was delta x, and the height of those was each the function at a different x value, so f of x sub 1, f of x sub 2, f of x sub 3. And then we found the area was approximately the sum of those, which we turned into a sigma. In this case, it goes to 3 of f of x sub k, delta x. And we made it more and more accurate by making it more and more subintervals. So we eventually got to this. Which we then turned into a definite integral, because that's the definition of what a definite integral is. Now, with that in mind, what we're going to be doing here, some of this is going to revisit what we just did, and some of this is just going to be like straight up, use your reasoning. So if you look at the stuff for 8.4, 8.4 is all about the area between two curves. It's like the basic concept. So if I wanted the area between F and G, the simple idea here is I would take the area under F, which is all of this blue stuff here, and I would take away the area under G, which is all of this green stuff here, and that would leave me with the yellow stuff. So essentially the area between two curves can be thought of as finding the area of the top curve minus the area under the bottom curve. Now, because those definite integrals have the same endpoints, we can combine those into one integral and write this. The integral from a to b of f of x minus g of x with respect to x. So this is how you find the area between two curves. Now, sometimes you'll be given the a and the b, the endpoints. Sometimes you'll have to calculate them because they might be like the intersection points of the curves. Now, that's 8.4 in a nutshell. 8.5 is the same idea, except in 8.5, you're given functions that are determined, they're given in terms of y. Now, if you look at this region that I've given, you know how we were building rectangles? In the 8.4 region, if I built rectangles, I should be drawing those in yellow, the same function is on top and bottom the whole time on the rectangles that I would build in that region. It's always f of x on top, always g of x on bottom. So that's why the f of x comes first in this and the g of x comes second, right? If I tried to do the same thing with these rectangles on this 8.5 stuff, we would start out with a parabola on top and the line on bottom. But right when we hit this point, we would have the parabola on top and bottom. So we would not only have to break this into two separate integrals, one where the parabola is on top and one where the lines on bottom, and then one where parabolas on top and on bottom, we'd also, because this is a rectangle has delta x as its width, we'd have to get everything in terms of x. And the functions we're given are in terms of y. And sometimes that can be really painful. So what we're going to do instead of all that is, instead of thinking of building the rectangles like we normally would, if you think about building them sideways. So basically, if I built my rectangles like this, if I look at that, then the bigger part of the rectangle, the highlight, what we normally would call the top, is always this parabola, because those are all the bigger values. And the bottoms of all the rectangles are always the line. Those are the smaller values. Now, here's the thing with this. When you do this, instead of the width of each of your rectangles being delta x, like it was in the original thing that we did, the width of your rectangles is going to be delta y. So that means your definite integral is going to come out in terms of y. So everything in your integral, when you have this thing that's like delta y, it sets your definite integral being dy, everything in your interval needs to be in terms of y. Now, when we were talking in 8.4 about what's bigger and what's smaller, it's easy to see. The thing on top is bigger, the thing on bottom is smaller. When you're dealing in terms of y, though, you need to know which x values are bigger and which x values are smaller, unlike y's being bigger and y's being smaller like it was in 8.4. So when you're thinking bigger and smaller and you're doing things in terms of y, think the function to the right and the function to the left. The function to the right is the bigger one, the function to the left is the smaller one. So when we do this 8.5 stuff, this would be f of y minus g of y, that's a y, looks like a g, with respect to y. F of y is the rightmost, g of y is the leftmost, bigger, smaller. Now, the tricky part with this too are the endpoints. You know, when we were doing the definite integral in 8.4, the endpoints were x values. Since this is a dy integral, the endpoints need to be y values. So the formula looks exactly the same as what we had above, except in terms of y's, but you just have to look at it differently. Bigger is to the right, smaller is to the left, and make sure your endpoints are y values. Now, 8.6, probably easier than 8.5 to conceptualize. Here we have two functions that cross each other at multiple points. So if you think again of the areas being what we did in 8.4, top minus bottom, we have two regions here. We have one region where f of x is on top and g of x is on bottom, and then we have another region where g of x is on top and f of x is on bottom. So if I look at the intersection points that I have, let's call those A, B, and C, if I then write the definite integrals for each of those things, the definite integral for the red would be the definite integral from A to B. The thing that's on top is f of x. The thing that's on bottom is g of x. That will give me the area of the red. And then when I get to the yellow region, it'd be the definite integral starting at B and going to C, but now g of x is on top, so g of x goes first. So essentially, anytime the functions like switch places, you have to write a separate integral where the thing that's on top goes first. And if it crossed with a y, it would be the thing that's on the right goes first. So now you can start working on some FRQs that are based on this stuff and get some practice in the concepts.